Hello and welcome everyone. This is Muhammad Izamam from SAIMEDHA ECET Coaching Center Koti, Hyderabad. SAIMEDHA Koti, Hyderabad is providing a golden opportunity to all the ECET 2024 and as well as ECET 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, SAIMEDHA Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. ర్యాంక్స్ గురించి చెప్పాలంటే SAIMEDHA Koti, Hyderabad లో every single year we have proven that maximum ranks in all the branches ECE, EEE, mechanical, civil and computer science లో top 5 branches లో state first rank తో పాటు maximum ranks in top 10 and top 50 లో కూడా maximum ranks are there. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches subject wise and as well as topic wise. Previous ECET examination questions will be explained by expert faculties. My dear students, గుర్తుపెట్టుకోండి, ఓన్లీ ప్రీవియస్ ఇయర్ కాంపిటేటివ్ ఎగ్జామినేషన్ క్వశ్చన్స్ కొరకే సపరేట్ కోర్స్ ఉంటుంది, పే చేయాల్సి ఉంటుంది బయట మార్కెట్లో. కానీ SAIMEDHA Koti, Hyderabad లో ఫ్రీ ఆఫ్ కాస్ట్ we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous ECET examination questions with which you can understand the level of teaching, the expertise which is there in the SAIMEDHA Koti, Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the ECET 2024 and ECET 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video.
Students, here we are discussing previous ECET questions in transmission line subject. First question is ECET 2009 question, standing wave ratio should be. So we know that in a transmission line when the load impedance ZR is equals to Z0, when the load impedance ZR is equals to Z0 means what? When the load impedance is equals to characteristic impedance, then we are saying that the transmission line is perfectly matched. So remember one condition here, when the transmission line is perfectly matched means when ZR equals to Z0. In this condition what happens, complete the wave, incident wave will be transmitted to load side. But when the transmission line is mismatched, that means ZR is not equal to Z0. When ZR is not equal to Z0, then the transmission line is mismatched. So when the transmission line is mismatched, then some incident wave at load will be reflected back. Some incident wave will be reflected back. So due to this incident wave and reflected wave, what happens? Standing waves will be exist. That is the concept of standing waves. So remember here, when standing waves will be existing means when the transmission line is mismatched. And remember, at what condition transmission line is mismatched means when ZR is not equal to Z0. So if ZR equal to Z0, no signal will be reflected from load towards source. So here when ZR is equals to Z0, there is no standing waves, the wave completely reflected. So when the wave completely transmitted towards source, there is no reflection coefficient. So what is the reflection coefficient? When the transmission line is perfectly matched, K equal to 1. When reflection coefficient equal to 1, then standing wave ratio formula in terms of reflection coefficient is SWR is equals to 1 plus mod K by 1 minus mod K. This is the relation between standing wave ratio and reflection coefficient. So SWR is equals to 1 plus mod K by 1 minus mod K. Then what happens? Standing wave ratio becomes infinity. Standing wave ratio becomes infinity. See here, because 1 plus 1 minus 1, this one. And similarly, when ZR is equal to Z0, then what is the value of K? 0. What is the value of K? 0, because K equal to formula ZR minus Z0 by ZR plus Z0. ZR minus Z0 by ZR plus Z0, when the transmission line is perfectly matched, there is no reflection. When there is no reflection, K equal to 0. When K equal to 0, then standing wave ratio is 1. Standing wave ratio value is what? 1. So here our question is, standing wave ratio should be. Standing wave ratio should be, always remember should be means ideal case is asking, so answer is 1. 1 means option is 2. Answer is 1, option is 2 because option 2 is 1. Remember. So standing wave ratio should be 1. If standing wave ratio 1 means what? There is no reflection. When there is no reflection means what is the value of K? 0. What case K becomes 0? When ZR equal to Z0. ZR equal to Z0 means what? When the transmission line is perfectly matched. So remember here only one point. When transmission line is perfectly matched, then ZR equal to Z0. When ZR equal to Z0, there is no reflection. When there is no reflection, K equal to 0. When K equal to 0, standing wave ratio becomes 1. So the ideal value of standing wave ratio is what? 1. So our question is, standing wave ratio should be, the correct answer is 1. Option 2 is correct. Next question. This is also 2009. A 75 ohms transmission line is terminated in a load of 100 ohms and it has some incident power. Then what is the percentage of reflected power is asking. So here the characteristic impedance of transmission line, is given as 75 ohms. The characteristic impedance of transmission line is given as 75 ohms. It is terminated with a load of 100 ohms. So I am giving here the load value. What is the load value here? Is given 100 ohms. So here ZR means what? Load impedance 100 ohms. Z0 characteristic impedance, that is 75 ohms. So here I am writing K equal to ZR minus Z0 by ZR plus Z0. Reflection coefficient K equal to ZR receiving end impedance, Z0 characteristic impedance. So K equal to ZR minus Z0 by ZR plus Z0. Here ZR equal to 100 ohms. ZR is given as 100 ohms and Z0 is given as 75 ohms. Then the reflection coefficient K equal to, I am writing 100 minus 75 divided by 100 plus 75. 100 minus 75 divided by 100 plus 75. 100 minus 75 means how much? 25 divided by 175. So I am writing 25 5 ja 125, 25 6 ja 150, 25 7 ja 175, 1 by 7. So what is the reflection coefficient value here? 1 by 7. Now is asking the reflected power value. So here we know that reflection coefficient formula in terms of voltage VR by VI, in terms of current IR by I, but when the reflection coefficient can be expressed in terms of power, K equals to under root of PR by PI. So I am writing here reflection coefficient formula in terms of power, K is equals to under root of PR by. So K value just now we calculated 1 by 7, then I am writing PR by PI, reflected power by incident power, is equals to 1 by 49. 1 by 49. 1 by 7 whole square, 7 square means how much? 49. Then is asking percentage of reflected power. So PR is equals to, I am writing 1 by 49 into 100 of PI. So 49 1 ja 49, 49 2 ja 98, 2 point something. So 2% of incident power. 2% of incident power means option 1 is the correct answer. Here load impedance is given, characteristic impedance is given, but is asking reflected power. So first you calculate reflection coefficient by using ZR and Z0. After that, calculate reflected power in terms of incident power. So here option 1 is correct. What is the answer? 2%. Next question, question number 3. This is 2009 question. The shunt admittance of a transmission line is given by. So this question is related to equivalent circuit of transmission line. So we know that the transmission line equivalent circuit, consists R in series with an inductance L. Here parallel combination, it is G in parallel with a capacitance C. So these 4 parameters are known as primary constants: R series resistance, L series inductance, G shunt conductance, C shunt capacitance. R series resistance, L series inductance, G shunt conductance, C shunt capacitance. And here the resistor and inductor are in series, then the series impedance Z is equals to formula R plus J omega L. What is series impedance formula? Z equals to R plus J omega L, and here G and C are in parallel. The shunt admittance Y is equals to formula G plus J omega C. The shunt admittance is what? G plus J omega C. Here the question is the shunt admittance of a transmission line is asking. So what is the answer? G plus J omega C. Option 3 is correct. Sometimes is asking series impedance also, that is R plus J omega L. By using series impedance and shunt admittance, we are calculating the secondary constants of transmission line, which are characteristic impedance and propagation constant. Here the shunt admittance of a transmission line is asking. The correct answer is G plus J omega C, option 3. Next question, question number 4. This is also 2009 question. A 300 ohms twin load is used to connect the receiving antenna to the receiver with an input resistance of 75 ohms. Then the standing wave ratio on the transmission line. So here is asking standing wave ratio. Standing wave ratio is asking. So to determine standing wave ratio, first we are calculate reflection coefficient. What is reflection coefficient formula? In terms of standing wave ratio or standing wave ratio formula in terms of reflection coefficient, SWR is equals to 1 plus mod K by 1 minus mod K. Here what is the meaning of mod K? Magnitude of reflection coefficient. Magnitude of reflection coefficient. So determine standing wave ratio. First we calculate reflection coefficient. Here reflection coefficient formula in terms of ZR and Z0. K is equals to ZR minus Z0 divided by ZR plus Z0. ZR minus Z0 by ZR plus Z0. What is the ZR value is here? 300 ohms, and Z0 value is how much? 75 ohms. So I am writing here ZR equal to 300 ohms and Z0 equal to 75 ohms. 300 minus 75 divided by 300 plus 75. That equals to 300 minus 75 means 225 divided by 375. And I am dividing with 5. 225 divided by 375. 5 4 ja 20. 2 remaining. 5 5 ja 25. 5 7 ja 35, 2 remaining, 5 5 ja 25. 5 5 ja 25. Again I am dividing with 5. 5 9 ja 45. 5 1 ja 5, 2 remaining, 25. 5 15, 75. So 5 3 ja 15. Sorry. 5 3 ja 15. So 5 1 ja 5, 2, 5 5 ja 15. So what is the value? 3 3 are 9, 3 5 are 15. So reflection coefficient K equal to 3 by 5. 3 by 5 means what is the value? 0.6. What is the reflection coefficient value here? 0.6. So ZR value is 300 ohms, Z0 value 75 ohms. Then substitute these two values, K equal to 3 by 5, 0.6. Then standing wave ratio. Then standing wave ratio is asking SWR is equals to 1 plus, what is the reflection coefficient value? I am writing 3 by 5 divided by 1 minus 3 by 5. 1 plus 3 by 5 divided by 1 minus 3 by 5, that equals to 5 plus 3, 8 by 5 divided by 5 minus 3, 2 by 5. 8 by 5 divided by 2 by 5. 8 by 5 divided by 2 by 5, that equals to, I am writing 2 1 ja 1, 2 2 ja 2 1 ja 2, 2 2 ja 2 4 ja 8. 2 1 ja 2, 2 4 ja 8. Therefore, standing wave ratio value is how much? 4. This is the answer. So option 1 is correct answer. So here what is the answer? Standing wave ratio equal to 4. 300 ohms twin load is used to connect the receiving antenna to the receiver with an input resistance of 75 ohms. Then the standing wave ratio is. So first calculate reflection coefficient, that is formula here K equal to ZR minus Z0 by ZR plus Z0. From that reflection coefficient value is 0.6. Then by using reflection coefficient we are finding standing wave ratio. Standing wave ratio equals to 1 plus mod K by 1 minus mod K. So what is the answer here? 4. Option 1 is correct. Next question, question number 5. A 300 ohms transmission line is terminated in a load impedance of 100 plus J200 ohms. Then the reflection coefficient is. Here transmission line is given, the characteristic impedance of transmission line is how much? 300 ohms. 300 ohms. And it is terminated with a load impedance of, ZR value, ZL value is also given. What is the value here? 100 plus J200. 100 plus J200 ohms. 100 plus J200 ohms. 300 ohms transmission line is terminated with a load impedance of 100 plus J200 ohms. Then is asking reflection coefficient. Same formula, K equal to ZR minus Z0 by ZR plus Z0. ZR minus Z0 by ZR plus Z0. Now I am substituting ZR value is how much? ZR equals to 100 plus J200 minus Z0 300 divided by 100 plus J200, that is ZR, plus 300. See here, 100 minus 300, that is minus 200 plus J200 divided by 100 plus 300, 400 plus J200 minus 200 plus J200 divided by 400 plus J200. So I am taking common 200 in numerator and denominator. Then K is equals to I am writing 200 is common, minus 1 plus J1, minus 1 plus J1, that is plus J, divided by 200, denominator also am common, 2 plus J. So 200 cancel. So from this, this is rectangular form, minus 1 plus J divided by 2 plus J. So under root of A square plus B square means 2 into tan inverse of B by A. B by A means 1 by minus 1 minus 1. Similarly, under root of 2 square plus 1, that is root 5 tan inverse of 1 by 2. Tan inverse of 1 by 2. Because we are converting from rectangular to polar form. So here minus 1 plus j, a plus jb, we are converting into polar form, that is under root of a square plus b square means root 1 square plus 1 square, that is root 2 into tan inverse of b by a, that is 1 by minus 1. Similarly here also 2 plus j I am converting into polar form, root 2 square plus 1 square, that is root 5 into tan inverse of 1 by 2. By simplifying this, you will get 0.6325 angle 108. 0.6325 angle 108 degrees. This is the answer. Option 1 is correct here. So this is fifth question answer. Here Z0 value is given 300 ohms, ZR value is given as 100 plus J 200 ohms. But here we require some calculation part, because rectangular form answer here, but options are given in polar form. You must know to convert, how to convert rectangular to polar as well as polar to rectangular.
So my dear students, for ECET 2024 and ECET 2025, SAIMEDHA KOTI Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi SAIMEDHA KOTI Hyderabad in this very week, guys. In this very week only, we are providing the maximum concessions. A concessions evaithe unnayo, concessions ఏ విధంగా ఉంటది, batches ఏ విధంగా ఉంటాయి, with materials, without material, online coaching, total మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్ లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి and join in the SAIMEDHA KOTI Hyderabad as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous ECET examination questions. I wish you all the best. This is Mohammad Inzamam signing off.